Welcome, everyone, to the Material Science series. In this deep dive, we are going to be talking about something that is quite literally changing the world. Batteries.
It really is incredible how much we rely on batteries these days. I mean, they're everywhere.
They are. Our phones, our
Yeah.
laptops.
Electric cars.
Yeah. Even storing energy from, like, solar and wind power. I mean, I know I can't live without my phone, but I have to admit, I don't really understand how they work.
Most people don't,
Yeah.
It's something we take for granted, but the science behind them, it's pretty mind-blowing. At the most basic level, a battery, you can think of it like a tiny energy storage system.
Okay.
And it has two main parts, an anode and a cathode. It's kind of like, the positive and negative ends of a battery that you see in a flashlight.
Gotcha. Okay. I'm picturing it. So what's actually happening between those two ends?
So the magic happens when these tiny little charged particles called lithium ions, they move from the cathode to the anode. And as they do that, they carry energy with them. And so that's basically what's happening when you charge a battery. And then when you use your device, those ions, they flow back from the anode to the cathode, and that releases the stored energy to power your phone or laptop or whatever you're using.
So it's like this constant flow of energy back and forth.
Yeah, exactly. Now, to make this whole process work, you need some very specific materials. We're talking lithium, of course, but also cobalt, nickel, manganese, graphite. And these materials make up the anode cathode and the electrolyte. The electrolyte, you can kind of think of it as like a pathway for the lithium ions to move between the two.
Okay, so it's starting to click for me now. So each material has like a specific role to play.
Absolutely. Imagine the lithium ions are like tiny delivery trucks, and they're carrying little packages of energy. And the cobalt is like the dispatcher, making sure those trucks are running smoothly and safely. Nickel, you can think of it as the fuel providing that extra boost for those long hauls.
Yeah.
And then graphite, well, that's like the smooth highway that the trucks travel on, making sure that the delivery is efficient.
Okay, wow. That is a great way to visualize it.
Yeah.
But I've heard that some of these materials like cobalt can be a little problematic.
Yeah, that's right. There are growing concerns about the ethical sourcing of cobalt and the environmental impact of mining some of these materials. So that's why scientists are always looking for alternatives, and that's where things get really interesting.
Ooh, I like when things get interesting.
Yeah.
So what are some of those breakthroughs that are on the horizon?
One of the most exciting developments is the solid-state battery. Instead of using a liquid electrolyte, which, can be flammable, it uses a solid one. A lot of times these are made from ceramic or polymer.
So no more exploding phone batteries. I'll take it.
Yeah.
But besides safety, what other advantages do solid-state batteries offer?
Well, for one, they could dramatically increase energy density. So think electric cars that can go twice as far,
Wow.
or smartphones that can last a whole week on a single charge. And they could charge much faster, too, so no more waiting around for hours for your devices to power up.
That sounds incredible. But what about those ethical sourcing concerns that we talked about with cobalt? Are there any solutions in sight for that?
Yeah, definitely. One promising alternative is the lithium iron phosphate battery, or LFP for short. These batteries are already being used by companies like Tesla, and they're cheaper, safer, and more stable than cobalt-based batteries.
So LFP could be a real game changer.
Absolutely. It's a great example of how material science is really driving us towards a more sustainable future. And speaking of sustainability, there's another contender in the battery race that's making waves, sodium-ion batteries.
Sodium ion, wait, like table salt.
You got it. Sodium is super abundant and much cheaper than lithium. Now, sodium-ion batteries, they may not have the same energy density as lithium-ion, but they're perfect for applications where cost is a major factor, like storing energy on the power grid.
So different batteries for different needs.
Exactly. And the innovations don't stop there. Researchers are also exploring the use of silicone anodes, and these have the potential to significantly boost battery capacity.
Okay, how much are we talking here?
Well, imagine a battery that can store 10 times more energy than what we have today.
10 times. That's mind-boggling. So we're talking about phones that last like a month on a single charge.
Well, not quite yet. Silicon has its challenges. One of them is that it swells during charging and discharging. But scientists are finding some really clever ways to overcome these obstacles.
It feels like there's just so much happening in the world of batteries right now. I'm feeling a little overwhelmed, but in a good way.
It's a fast-moving field, that's for sure. But that's what makes it so exciting. These advancements aren't just about making our devices better. They're about creating a cleaner, more sustainable future for everyone.
Yeah, I'm really starting to see the bigger picture here. This is way more than just making my phone battery last longer. This is about tackling climate change, reducing our reliance on fossil fuels, and creating a world where renewable energy is truly viable.
Precisely. And that's why material science is so important. It's the foundation for all of these innovations. It's the driving force behind a more sustainable and electrifying future. It's amazing to think that all these advances are happening because we're manipulating materials at like the atomic level. We're building batteries from the ground up, atom by atom.
It's mind-blowing. So with all of these different battery technologies that we've been talking about, solid state, LFP, sodium ion, silicon anodes, is there going to be like a winner? Like, is there one that's going to be the best?
That's a great question, but I don't think there's a one-size-fits-all answer. Each technology, it has its own strengths and weaknesses, so it really depends on the application.
Oh, so it's more like a toolbox of battery solutions.
Exactly. Think of it this way. If you need a battery for like a long-range electric car where energy density is super important, solid-state batteries might be the perfect choice.
But if you're more focused on keeping things affordable, like for storing energy from solar panels on your roof, then sodium-ion batteries might be a better option.
Exactly. And for applications where size and weight are really important, like in smartphones or wearable devices, those silicon anodes with their potential for, increased capacity could be a game changer.
It's fascinating how material science is driving all of these innovations and creating so many possibilities. It's almost like each material has its own unique personality and potential.
It really does.
Yeah.
And the advancements, they aren't just limited to the materials themselves. Researchers are also exploring new designs and architectures for batteries. So, for example, they're experimenting with three-dimensional structures that can pack more energy into a smaller space.
So we're not just changing like the ingredients, we're redesigning the entire recipe for batteries.
Precisely. And that's where nanotechnology really comes into play. By being able to manipulate materials at the nanoscale, and that's a billionth of a meter, scientists can create structures with incredible properties that can really enhance battery performance.
It's amazing that we're harnessing these tiny little building blocks of matter to create such powerful technologies. But with all this talk about building better batteries, what happens to all the old ones?
That's a crucial question. Battery recycling is absolutely essential for creating, a truly sustainable battery ecosystem. As the demand for batteries keeps going up, 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 we need to develop really effective ways to recover and reuse those valuable materials they contain.
Otherwise, we're just going to end up with a mountain of battery waste, right?
Right.
And that can't be good for the environment.
Exactly. Recycling batteries not only reduces waste, but it also lessens our reliance on mining, which can have a big environmental impact.
So recycling is like closing the loop on the battery life cycle.
Precisely. And it's not just about recovering materials. Researchers are also looking at ways to repurpose old batteries for, less demanding applications, like storing energy from solar panels in homes.
So even a dead battery can have a second life.
Absolutely. And as battery recycling technologies get better, we can expect to see even more innovative ways to reuse and repurpose those valuable resources. It's all about creating a more circular economy for batteries where materials are kept in use for as long as possible.
It's encouraging to know that as we're searching for better batteries, we're also focusing on sustainability and responsible practices.
It's all connected. And as we continue to, explore the frontiers of battery technology, we need to keep this kind of holistic perspective in mind.
Well, I'm starting to see that the world of batteries is a lot more complex and fascinating than I ever thought.
It really is, and we've only just scratched the surface. But, before we go any further, let's take a step back and talk about like the heart of all of these battery technologies, the underlying chemistry that makes it all possible.
Okay, let's get down to the nitty-gritty.
At its core, a battery operates on the principle of redox reactions. That stands for reduction and oxidation. Essentially, it involves the transfer of electrons between two materials.
Electrons, those tiny negatively charged particles.
Yes. Think of it this way. When you're charging a battery, electrons are basically forced from one material, the cathode, to the other one, the anode. And this creates a difference in electrical potential energy between the two.
So it's like building up a charge.
Exactly. And when you use the battery, those electrons, they flow back from the anode to the cathode through an external circuit, and that releases the stored energy powering your device.
So that flow of electrons is what we harness as electrical current.
You got it. And the electrolyte, the material that's sitting between the anode and the cathode, that plays a crucial role by allowing ions to flow, and that ensures a smooth and balanced transfer of charge.
Okay, I'm starting to see how it all fits together. But with all these different types of batteries, are the underlying chemical reactions all the same?
The basic principle of those redox reactions stays the same, but the specific materials that you use for the anode, cathode, and electrolyte, that's what dictates the voltage capacity and, other performance characteristics of the battery.
So by tweaking the materials and their interactions, scientists can fine-tune the battery for different applications.
Precisely. And that's what makes battery research so exciting. There's like a vast chemical playground out there to explore with just countless possibilities for creating batteries with, very specific tailored properties.
I'm starting to feel like I'm peeking behind the curtain of like a magic show and seeing all the intricate little mechanisms that make it work.
It's kind of like that, isn't it? And just like a magician never reveals all of their secrets, there's always more to discover in the world of batteries.
Well, I'm definitely hooked. And speaking of discoveries, I'm really eager to learn more about the real-world impact of these battery advancements. So when we come back, let's dive into the exciting applications that are shaping the future, from electric cars to renewable energy and beyond. All right, so we've talked about how batteries work and all those crazy advancements in material science, but let's step back and look at the bigger picture. How are these little powerhouses changing the world?
Oh, the applications are huge. And they're growing fast as the technology keeps evolving. Electric vehicles are an obvious example. But we're also seeing electric buses and trucks. Even electric airplanes are on the horizon.
Electric airplanes. Now that's something I got to see.
I know, right? It does sound a little futuristic, but there are actually several companies out there already developing and testing electric aircraft. It's still early days, but the potential is enormous. Quieter, cleaner, more efficient air travel, yes, please.
Talk about a game changer, not just for travel, but for the environment too. But it's not just transportation, is it? I mean, what about renewable energy? What role do batteries play there?
Oh, batteries are essential for the transition to renewable energy. Think about it. One of the biggest challenges with sources like solar and wind is that they're intermittent. The sun isn't always shining, the wind isn't always blowing.
Yeah, that's true. So how do we get a steady supply of energy from these sources? Batteries come in here, right?
Exactly. These large-scale battery storage systems, they're like giant reservoirs. They can store all that excess energy that's generated during peak production times and then release it when demand is high, but renewable generation is low.
So they smooth things out and make sure there's a reliable flow of electricity to the grid.
Exactly. And as batteries keep getting better and cheaper, we're going to see even more renewable energy integrated into our power systems. It's paving the way to a cleaner and more sustainable future.
So these little batteries are having a huge impact. What about other applications that aren't so obvious? What else is changing?
Well, we already talked about portable electronics, but think about medical devices.
Peace?
Pacemakers, defibrillators, insulin pumps. Those are life-saving devices that need tiny, long-lasting batteries to work.
Wow, so batteries are literally keeping people alive.
They are. And then there's robotics. Advanced batteries are allowing us to develop more sophisticated and autonomous robots. Robots that can explore dangerous environments or assist with complex surgeries.
Sounds like batteries are everywhere, touching every part of our lives.
They really are. And we're just getting started. As material science keeps advancing, we're going to see even more incredible and transformative applications in the years to come.
This deep dive has been so eye-opening. I really have a whole new appreciation for batteries now. They are incredible.
I agree. It's a fascinating field, and it's constantly changing. I encourage everyone to stay curious and keep learning about all the new developments in battery technology.
And speaking of learning more, be sure to check out the Material Science website. You'll find the link in the podcast details. There's a ton of great information there.
You'll be amazed by what you find.
Well, that's all the time we have for today. Thanks for joining us on this electrifying journey into the world of batteries. Until next time, keep those minds charged up and stay curious.